So we're looking at simplifying radicals with variables this time. So if we look, let's just deal with x. So if we have x times x, that equals x squared. So if we wanted to take the square root of x squared, remember the square root undoes squaring, we'll end up back with x because the square root is asking you what number times itself will give you this. So what if we did x squared times x squared? Well, that becomes x to the fourth power. So if I wanted the square root of x to the fourth, I get x squared. If we look at x cubed times x cubed is x to the sixth. If we're going to take the square root of x to the sixth, remember you're asking yourself what number times itself will give us x to the sixth. Or you can think about the square root undoing the squaring. X cubed. And one more, and then we'll move on. X to the fourth becomes x to the eighth. If you notice a pattern, we're adding them to get there. And square root of x to the eighth is going to be x to the fourth. Hopefully, you're noticing another pattern there. Do you notice that here we have 2, and then this is 1? Nothing written there means it's 1. Here's 4 and 2, 6 and 3, 8 and 4. Hopefully you're noticing, oh look, the square root is half of the original exponent. So when we take the square root, we divide the exponent in half. Well, then comes the question, well, what if we have something like the square root of x to the 100th? Well, you would just divide it in half. You would have x to the 50th. Well, what happens if we try and take the square root of an odd number, like x to the 7th? If I divide that in half, it would be 3.5, and we don't want that. In high school, they don't want that kind of an answer. So what we do is we break this up, and we say, well, x to the 7th is x to the 6th times x. We have 6 here plus the 1 here, which would make x to the 7th. Just like we used to pull out the perfect squares, we pull out the even. You can always just take 1 away, right, and you'll have an even number. Then the square root of x to the 6th is x cubed, and you can't go any further with this, so it's just left as x. So let's do a few examples. The square root of x to the 10th. We don't have to limit ourselves to just one variable. We can have multiple variables on the same radical. You just treat each one individually. So x to the 10th, divide 10 in half, we get x to the 5th. Divide y to the 6th, the square root of y to the 6th becomes y cubed. We don't have to be limited to x and y. What if we had a to the 4th and b to the 100th? I just break them up and treat them individually. That would be a squared, because half of 4 is 2, and b to the 50th. Well, now we can combine in numbers and variables. What if we had 4x to the 8th? Break it up to be the square root of 4 and the square root of x to the 8th. Well, what's the square root of 4? Oh, we know that. That's 2. What's the square root of x to the 8th? X to the 4th power. Doesn't quite look like an 8. There you are. Well, let's make it more challenging, huh? What about 75, a to the 5th, b to the 6th? We can get these to be really long. We just treat them the same way. Break them up into pieces. The square root of 75, the square root of a to the 5th, and the square root of b to the 6th. So for the 75, we go, okay, what perfect square can I get out of there? Oh, 25 times 3 is 75. A to the 5th, I need to take 1 away so that I can divide it in half. And then b to the 6th. Square root of 25 is 5. I can't do anything with the square root of 3. Square root of a to the 4th is a squared. Can't do anything with that. Square root of b to the 6th is b to the 3rd. And then I combine my leftovers, the 3 and the a, underneath the radical. And there's our final answer. And I'm out of time. That is where we'll stop.